All right, hello, I'm Mr. Solt, and I'm going to be doing Mr. Baskin's Algebra 1 GN word problems with quadratics, okay? So I think this is general notes, word problems with quadratics. It's a teacher-made assignment. If you click on this and you sign in with Google, you'll get something that looks like this. Quadratic word problems, Common Core Algebra 1. All right. I'm just going to go through these exercises. I think these are just the general notes. I think Mr. Baskins wants you to know all these, and then I'll leave the homework part for you guys. So I might do some of these general notes things just to help out, and we'll see if this helps anyone. All right. So you guys, looks like you guys have been looking at the zero product rule as a method for solving quadratic equations that are factorable when set equal to zero. And we can also model scenarios that are quadratic in nature and solve them for rational solutions with factoring. So we're going to demonstrate some of that right now. Exercise 1. Consider a rectangle whose area is 45 feet. All right. I'm already like, oh, I don't know. So here's what I recommend. Whenever they say consider a rectangle, start, just draw it out. Just draw out. Oh gosh, so I don't deal with teacher made too often. Let me see if I can do this. Do I have to draw? I have to draw on the thing, don't I? Okay. So I'm going to consider a rectangle whose area is 45 feet, and I'm going to do so just by drawing a hypothetical triangle. Oh, sorry, hypothetical rectangle, rather, and the area is 45. So I'm going to draw a 45 right inside here. So I know the square area of the whole rectangle is 45 square feet, even though I don't know the length or the width yet. If we know the length is one less than twice the width, then we would like to find the dimensions of the rectangle. Okay, now let's think about this. We know that the length is one less than twice the width. Well, let's see if we can talk about that. The length is one less than twice the width. So the width is something, and I don't know what it is. I don't know what that something is, but I can just call it x, right? I can just call w is equal to a variable that I don't know. And sometimes in math, when we have a variable we just don't know, sometimes we just call it x. Pardon me. All right, so I know the length. I know what the length is in relation to the width. The length is one less than twice the width. Okay, so let me think about that again. The length is one less than. It's one less than. So I could say like minus one. It's one less than twice the width. Well, I don't know what the width is, but if I give it a variable called x, I can just call it 2x. Kind of feel how that goes, right? If the width is x and the length is one less than twice the length, I'm sorry, if the length is one less than twice the width, I should say, then the length could be expressed as 2x minus 1, and the width could just be expressed as x. So I could just put an x here. And then I could say the length is 2, x minus 1. All right, okay. So now I need to then write an expression for the length of the rectangle, L in terms of W. So when it said in terms of W, I probably should have read this whole thing out once, because that in terms of W would have given me a hint that I need to make W equal to X, right? I'm going to put this in terms of W. Okay, so I need to write an expression for the length of the rectangle in terms of W. So I could say L is equal to 2W. They want me to write in terms of W. So I can't just call it x. They want w to be equal to w. So I can't call it x. I could have saved myself some time by reading the whole thing out first of all. So the length is equal to 2w minus 1. 2 widths minus 1, right? Because we know the length is 1 less than twice the width. So length is 1 less than twice the width. Okay, that's my equation right there. That's my answer to this little first piece. L equals 2w minus 1. Set up B here says set up an equation that could be used to solve for the width based on the area. Let me give yourself a time to think about this. How would you set this up? What could you do right now to say, I know how these things are related. I know how length and width is related to area. How could you set up that as an equation? The beauty of video is you can pause me at any time. Get yourself some think time. Through the magic of video, you pause me, I'm unpaused. All right, let's think about this. So I got to set up an equation. Well, I know, maybe you know from a long time ago that, length times width equals this capital A area, right? The area of a rectangle is just the length times the width. You remember that, right? Well, in this case, I know that the length is 2w minus 1. 2w minus 1. And then I know the width is going to be, what I'm going to call it w, should equal, not, I'd be tempted to put an A, except I know what the area is, right? That's 45. I knew that from before. So 45. And now, can I solve this equation? I have one equation, and I have only one variable. This is solvable. This is solvable. First, I got to multiply these two things together. And remember, I've really got to take care to use this as I got to distribute the w across this expression, right? Because length is this whole expression. Length just isn't -1 or 2w. It's the whole expression here. So I got to distribute the w across. So w times 2w, right? What it would be, w times 2w would be 2w squared. 2w squared. W times 2w would be 2w squared. And then w times -1 would be -1w. All equals 45 still. And this is where I kind of run out of space on my page to do things. Maybe I'll have to go this up. But I have what's the makings here of a quadratic. Oh, yes, I do. I have the makings of a quadratic. I am going to subtract 45 from both sides of this equation. Because if I subtract 45 to both sides, really tiny. If I subtract 45 on both sides, this becomes 0. And now I can use the zero product law. Remember that? The zero product law to solve for this quadratic. So let me try this. Let me try to, can I write up here? I can write up here. 2w squared minus 1w minus 45 equals 0. All right, okay. So let's see if this is factorable. Let me think about, maybe I can save myself some time and not have to break out the quadratic formula on this guy. I know somewhere I multiplied 2w times a w. How do I know that? Because, I'm going to put a 1 in front of there. I know that because the only factors of 2, I got to think about what two things can multiply together to be 2. And there's really only two numbers that multiply together to be 2. It's 1 times 2. Only 1 times 2 will give me 2. So I know that there had to be a 2w over, and how do I know that both of them had a w? Because this w squared thing. W squared means there had to be two w's being multiplied with each other. All right, now I got to think of, okay, factors of 45, there's a couple of those, where if I multiply one of those factors by 2 and then add them up where one of them could be negative, I get -1. So this is a little more difficult. Let me think about the factors of 45. 1 times 45 works, but that's probably not going to be what I'm looking for. I don't see a way of making that one work. What about 2? 2 doesn't work here. 45 divided by 3. Now that works, doesn't it? 45 divided by 3. 15. Let me think. Could I take 2 times 3 and get, no, that's not really going to work. What else can I have? Maybe 5. What's 45 divided by 5? 9. Let me think about that. So I'm thinking about the factors of 9 and 5. I'm thinking to myself, they both equal 45. That's good. If I multiply these two things together, I don't want that. If I multiply 9 and 5 together, not the 4. If I multiply 9 and 5 together, I get 45. One of these numbers has got to be negative, because I have a negative 45 here. So one of these numbers has got to be negative. And one of these numbers is going to get multiplied by 2, because I got a 2 sitting right here, just waiting to multiply to whatever I put over in this space over here. And I need to get a -1. I need to get a -1 when I add these things up. So I notice that 2 times 5 gives me 10. And if I make that 5 the negative, then that'll give me -10. And then -10 plus a positive 9 would give me a -1. So if I make this a positive, and I make this a negative, let me just kind of, FOIL this out and see if it works. 2w times 1w would be 2w squared. 2w times negative 5 would be negative 10w. Positive 9 times 1w would be positive 9w. And then positive 9 times negative 5, negative 45. Ooh, ooh, ooh. Good things are happening. I can see that if I combine these things two together, I get negative 1w. If I add this with that, I get negative 1w, and that's my original. That's my original. So I have some factors. Woo. Oh, stop writing. I have my original. I have my original. This is good. This is good. So this is a good this is a good fit. This is a good factor. It's to set up an equation that could be used to solve for the width based on the area. We actually have the equation right there. It could work. This is an equation that could be used. Does it tell us to solve? It gave me space to do all this down here. Solve to find both dimensions. Oh my gosh. Here I am trying to do everything all at once. Well, here's my thing. Two. Okay, teacher maid. You're being weird. Oh, okay. All right. Teacher maid just wants to be weird. Let me rewrite my equation here. 2w2 let's see, minus 1w minus 45 equals 0. And let me write my factored piece. 2w plus 9 in parentheses. And then 1w minus 5 parentheses equals 0. Now I'm getting somewhere in life. At least with this equation. All right. I have found an interesting result. By factoring these things into two things which are being multiplied together, I know that this whole big thing equals 0. And now I know that this factor times this factor equals 0. And the only way I can multiply two things and get 0 is if one or both are equal to 0. Right? So I could now begin to say, wait a minute. I know either this is equal to 0 or that's equal to 0, or maybe both, because 0 times 0 is still 0. But one of them's got to be equal to 0. So I could use that 0 product law, that 2w plus 9. That might be equal to 0. Let me see what that's going to be. Let me see what w is if this is equal to 0. I'll subtract 9. I'll subtract 9. And then I will divide by 2. All right. So I will get negative 9 divided by 2 equals 0. I wish I had more space to demonstrate that. So I'm going to have negative 9. No, that's a terrible 9. Don't make fun of my 9s. 2w. And then I'm going to divide by 2. That's a terrible 2. That's not better, but okay. Right, I'm going to divide by 2 over there to get rid of the w being multiplied by 2, which means I got to divide by 2 on this side. So w equals negative 9. I just had to do that. W equals negative 9 over 2. Negative 9 over 2. And I'm going to have to erase this to even see what I'm doing behind here. Okay, anyway. And then I have 1w. 1w minus 5. This is going to be a little easier. Equals 0. I want to add 5 over here. Because remember, I want to get w by itself to figure out what it's equal to. That gives me w, or 1w, equals 5. So w is either equal to 5 or w is equal to negative 9 divided by 2. So I've solved the equation. But it says solve the equation to find both dimensions. Why is one of these solutions for w not viable? Not viable. Think about that. Which one of these could work and which one of these just not possible? Hey, you can pause me if anytime. And now you've unpaused me. Great. Okay. Well, obviously I can't have, right? I can't have w equal to negative 9 over 2. I mean, what even is that? Negative 9 over 2. I gotta get that out of my way. Right? That'll be like a negative number. Negative, oh, no, not minus. Negative 9 divided by 2 would be negative 4.5. Right? And I can't have a width of negative 4.5. That doesn't even make any sense. So in the grand scheme of things, I have to just reject this as not viable, and I'm going to use w as 5. So if w is 5 over here, and I'm still calling it x, which I shouldn't be, I should be calling it w by now, and I probably should, get rid of that x there. Oh, it doesn't want to let me erase the x anymore. It likes the x now. Teacher made is a funky product. Okay, we'll deal with it. We will deal with it. No biggie. I'm just not used to it. I use other tools. Okay, so what's w? W is 5. That's equal to 5, right? And then if the width is 2 times, but 1 less than 2 times the width, then 2 times 5 is 10, minus 1 is 9. So this is equal to 9. And think about that. If the length is 9 and the width is 5, the area is 45. It all fits. It's all beautiful. The world makes sense again. All right? That's how it's done. That's how it's done. Okay. So I am going to use the eraser to get rid of this guy here because he's not even a viable answer anyway. And you'll just have to remember that he's not viable. All right. A square has one side increased in length by 2 inches and an adjacent side decreased in length by 2 inches. If the resulting rectangle has an area of 60 square inches, what was the area of the original square? First, draw some possible squares and rectangles to see if you can solve by guess and check, and then solve algebraically. All right, let me give this a shot. I got this square, and I'm going to try to make it squarish, but I will probably not succeed to make it perfectly square. That's my square-ish square. And I'm going to increase one side by 2. By 2. All right, the length increases by 2 inches, and the adjacent side is decreased in length by 2 inches. All right, so something like that. And then now, all of this is gone. All of that is gone. Okay, so I'm left with just this guy. All right. Well, here's how I'm going to go about this. I don't know what the length of the square was to begin with, but what if I just called this one side our favorite variable x, right? What if the length between here and here is x? Well, if I know that I increase this by 2, I could call the total length of this whole side x plus 2. And now that I have this side here, this could be x minus 2, right? Because I subtracted 2 units on this side. I don't know what x is yet. So let me play with some ideas. I know the resulting area has an area of 60 square inches. So this side has to multiply by this side to give me 60. What are some possibilities? Well, 10 and 6 are an obvious possibility. Let me see if that fits. Could the could this have been 8, right? If the square was 8, had a side length of 8, and I added 2, that would give me 10 on this side. And if I subtracted 2, it'd give me 6 on this side. Hey, a little guess and check, a little intuition, and that works. So x is 8. X is probably going to be equal to 8 here, right? Because I needed 2 numbers that would multiply together to give me 60, and there's not too many options here. We have, let's see, 6 and 10, 60 and 1, 30 times 2, 60 divided by 5, 12 times 5 is 60, right? We have a couple different options. We needed one option which gave us, where the two are basically, it's a difference of 4 from each other, and 6 and 10 just popped into my head as, hey, let's try that, and that just happened to work out very nicely. If the original square is 8 and we added 2, that gives us 10 on this side, And if the square was 8 on this side and we subtracted 2, give us 6. 10 times 6 is 60. That's the rectangles we were looking for. Solve it algebraically. Let me solve algebraically. I need x plus 2. You should probably actually pause the video now and give this a shot on your own before you see me do it. All right? Use the power of video to pause me and do this on your own. Try to express this algebraically if you can. Great, I'm unpaused. Okay. All right, well, again, the area of a rectangle is the length times the width equals the area, right? Well, I know, well, at least I'm guessing. They tell me that the area is 60 and that the one side length has been increased by 2, one side length has been decreased by 2. All right, now I got to multiply these two things together to figure out what's going on here. Let's see, I got x times x is x squared. That's x times x. X times negative 2 is negative 2x. And then, x 2 times x, sorry, my brain is flustered apparently right now. And then positive 2 times negative 2 is negative 4 equals 60. And of course, I'm going to do the little zero product rule. I'm going to subtract 60 right here to get negative 64 because I want this whole thing to be equal 0 in the end. I want to be able to use that zero product law. So you see that? I subtracted 60, and then I combine these two things. These two things cancel. Oh, look at that. I'm going back to the old problem. I'm using W instead of... I broke the rules. I broke the algebra rules. I'm not supposed to mix my variables up. These two are going to be the same. They actually cancel each other, right? A negative 2x and a positive 2x cancels each other, which gives me x squared minus 64. Can you solve that? Pause me and try to solve that right now. All right, great. You know that you learn more when you try these on your own. You learn a little bit by watching. You learn a lot more by doing. All right. Well, hopefully, I'm hoping you're noticing that negative 64 here is a perfect square, and x squared is a perfect square. So we can use one of those little factoring tricks to say, wait a minute. There's no middle term. So what I can do here is I can put an x there and an x there. That'll give me x squared. And 8 times 8 is 64. So if I put a positive 8 there and a negative 8 there, the middle terms will cancel. And then the c term will become negative 64, just like I want. Which means x is got to be either, this whole thing's going to be equal to 0, which means this is equal to 0, or that's equal to 0. If I put x equals negative 8 equal to 0, I'd have to add 8 to both sides, and I'd find out that x could possibly be 8. And if x plus 8 is equal to 0, then x has got to be equal to negative 8. And guess which one of these things I got to reject because one of these solutions are not viable, right? The negative 8 is not viable. So there it is. My x equals 8. Woo! It's not so bad, actually. It's harder to talk about than to actually get it done. All right. Did I do everything? I guess, yeah, we solved it algebraically. Great. Let's see. Word problems and strictly numbers. Okay, example. Exercise 3. Two rational numbers have the following property. When the product of 7 less than 3 times the number with 1 more than the number is found, it is equal to 2 less than 10 times the number. Whew. Find the 2 rational numbers that fit this description. Goodness gracious. Let me try to pick this apart. Well, what's a rational number? At least I know that I'm going to get a number that terminates nicely or that follows some kind of pattern. All right. When the product of 7 less than 3 times the number with 1 more than the number is found. Okay. The product means multiply, of 7 less, the product of 7 less than 3 times the number Okay, so I'm going to have a multiplication, and now I have 7 less than 3 times the number. Okay, I don't know what the number is, but in the classic spirit of mathematics, I'm going to call the unknown number to be x. And I know it's 3 times the number with 7 less. All right, 3 times 7 less the number. When the product, that's my multiplication thing here, of 7 less than 3 times the number with 1 more than the number is found. So it's the product of this with 1 more than the number. Well, x is the number, and 1 more than that would be x plus 1. It is equal to, this is going to be equal to 2 less than 10 times the number. Okay, 2 less than 10 times the number. Well, 10 times the number is 10x, and 2 less than 10 times the number would be negative 2. Whew, okay. Okay, well, in order to solve this, I'm going to have to multiply these two expressions with each other, and then this will turn into a quadratic. I already see those x's are going to combine, and then I'm going to have to get everything equal to 0 and solve using the zero product rule. Okay, so let me start. 3x times x to start. That's going to be 3x squared. Let me break out my little writing pad here. I'm struggling here with a mouse, and maybe this writing pad will provide some freedom for me. There we go. Oh, I can do better than that. I can do better than that. Okay. Let me try again. 3x squared. Okay, now it's going to be, so I already did this. Now I'm going to do this. 3x times 1 is plus 3x, right? 1 times any number is just itself. And then I wish I could switch colors. Can I switch colors? Oh, I can. That's nice. But teacher made, you actually have to let me switch the color when I press the color button. Oh. Okay, fine. I guess I'm stuck with blue. 7 times x is plus, negative 7x. And then negative 7 plus 1 is negative 7. Okay, and that's all going to be equal 10x minus 2. Got to combine my like terms here. The like terms I got to combine is this negative 7x and the plus 3, which gives me negative 4x. I still got the minus 7. I still got the 3x squared. And that's all still equal 10x minus 2. I'm going to subtract 10x. I'm going to add 2. It's not a 7, that's a 2. That's I'm trying to add there. Okay. Negative 10x plus 2. I don't know why that keeps looking like a 7. And let me pull it over here. I'm going to rewrite it. Rewrite 3x squared. Let's see. Negative 4x and negative 10x is negative 14. Negative 14x. And then what am I left with? Minus 5, right? Negative 7 and positive 2, negative 5, and then that all equals 0. Well, I got to be honest. When I get here, I am not a happy camper yet because I'm really hoping this is factorable at this point. So I'm just going to trust. I'm going to trust that it's factorable because I don't want to break out the quadratic formula after I've done all that work. I could, but man, there's not a lot of space left over. I got to think about factors of 3. Factors of 3, well, there's only 2 that really make sense here. There's a 3 and a 1. 2 numbers that multiply together to be 3. 3 and 1 is really much your only options. I see that x has got to be multiplied by x, so I know there must be an x somewhere here and an x somewhere there. That's a terrible... I don't know if it's teacher made or my board. I'm going to blame it on my board right now. Come on, come on. You delete that. That's the thing I don't. That's the thing I want deleted. Okay, thanks. Anyway, I guess I'll take it. Oh well. And okay, now I got to think of factors of 5. Well, that's good. I like that. I think about factors of 5. There's only 2 numbers that multiply together to be 5. There's 1 times 5. So there's got to be a 1 somewhere and a 5 somewhere else, where when I add the results together, I get negative 14. All right, I'm already liking the idea of putting the 5 right here. I like the idea of putting the 5 right here, and I'm sorry that this keeps getting weird. Sometimes I don't know if it's worthwhile to use the board now. And I'm going to put a negative 5. Thank you. And then I'm going to put a positive 1 here. Positive 1. And I think this is going to work. Let me think about it. 3x times x gives me 3x squared. 1 times negative 5 gives me my negative 5. And then my outer terms are negative 15x. And my inner term is positive 1x, which gives me that negative 14x like I'm looking for. This looks good. This was factorable. Life is good. I had to trust the process, trust the process. And does it tell me to equal? It says, yes, it says find the two rational numbers that fit this description. So let me see what the possibilities of x are. These two things multiply together to give me 0, which means either this equals 0 or that equals 0, or both. 3x plus 1, 3x plus 1 could equal 0, or maybe 1x minus 5 equals 0. Well, this one's pretty easy. If I add 5 over here, I could add 5 on the other side, and I get x. X is just equal to 5. I like that number. I hope that works out. That's my contender. Let's see if it works out over here. 3x plus 1 equals 0, minus 1, minus 1, and then I would have 3x equals negative 1, and divide by 3, and if I divide by 3, I get x equals negative 1/3. Now, is negative 1/3 a rational number? Does it have a nice terminus? All right. Right? So, negative 1/3 is not the rational number I'm looking for, right? I'm looking for the 5 is because it says it's a rational number, and negative 1/3 is not a rational. All right. It's going to be a number without a terminus. All right. So 5 is my boy. 5 is my boy right here. Yeah. Oh, wait. I'm taking it back. Let me take it back. It says find the two rational numbers that fit the description. They are looking. So I mean, negative 1/3 doesn't have a terminus, but it is irrational in terms of it has we know what the it's not going to be. Let me take it back. Let me make a newspaper correction. A repeating decimal is a rational number, right? Repeating decimal is a rational number. It's those ones that have no where it doesn't have a terminus, and it's like all sorts of random numbers going on. Not random numbers, but unpredictable numbers that don't have a pattern. Those are the irrational numbers. So we have our two rational numbers. These are our two. X equals 5 and x equals negative 1/3. Oh, please let this be done soon. Anybody else tired? I'm tired. Okay. And of course, who can forget work with consecutive integers from a linear unit? Find all the sets of two consecutive integers such that the product is 8 less than 10 times the smaller integer. Okay, all the sets of two consecutive integers. Let's talk about consecutive integers. What's it mean to be a consecutive integer? What's an integer? Think about it in your head. Okay, an integer is all the positive and negative whole numbers. Okay, integers are all the positive and negative whole numbers. And what does consecutive mean? Consecutive means they're right next to each other. Okay, so find all the sets of two consecutive integers such that their product is 8 less than 10 times the smallest integer. Okay, so I've got two numbers, and in traditional algebra fashion, we'll call the first one x, and we'll call his big bro x plus 1. I don't know why this keeps doing this little weird 7 plus, but that's just what it keeps doing to me. All right, two numbers. The first number is an unknown. The next number is the unknown plus 1 because they're consecutive. Their product. That means I have to multiply. It means if I was to multiply. Come on, play nice there, teacher maid. Play nice. Don't play me like that. X times. Come on, you can do it. X plus 1. I don't know why it does that weird thing every time. All right, these two things multiply together. Their product is means equals. Is an equals. 8 less than 10 times the smaller integer. The smaller integer is x. So 10 times x is minus 8. Whew. Okay, let me multiply these things together. X times x is our good old buddy x squared. That's the parent of the quadratics there. And then x times 1 is going to be positive 1 x. And then I'm going to end up subtracting I'm going to subtracting 10x. I'm going to add 8 to get rid of these two to make this whole thing equal to 0, which means I'm going to do a minus 10 over here, minus 10x, and a positive 8 equals 0. And I'm going to combine this whole thing. Sometimes I'm beginning to regret that I pulled out this pad. I got this nice little writing pad that helps me write, and usually it works great, but some apps not so much. And this today it seems Teacher Made is just not liking it. Okay, so that's a plus. That's a plus there for those of you playing at home. All right, so I got x squared minus 9x plus 8 equals 0. Let me see if I can do it to factor this thing. Let me see if I can take two things and multiply them together that will give me the same expression as this. Okay, I got x squared. That means I need two x's that get multiplied to each other. I got 8. Lots of different ways, lots of different factors of 8. There's 1 times 8, 2 times 4, and that's it. 4 times 2 and 8 times 1. All right, so I have limited options, and say I see a 9 here, so I definitely want to make one of these over here to be 8, which means I got to make the other one 1. I would like to get a negative number in the end. And since there's a positive here, I have to have either two positives or two negatives. I'm going to make them both negative. Kind of feel how I thought that through. This is a positive, which means I either have to have two positives or two negatives to get a positive, multiply together. And then this is a negative number, so I want two negatives. So there I go. I have two numbers, two expressions that when they multiply together give me 0, because this is equivalent to this over here. And that means either x minus 1 is going to be equal to 0, or x minus 8 is going to be equal to 0, in which case, x is either equal to 8 or x is equal to, see how that's going to, I know that's going to be plus 1. X is equal to 1. Two possibilities. There are two possibilities that actually solve this problem here. Two consecutive integers. Either the integer is 1 and 2, or the integers are 8 and 9. Right? X is either equal to 1 or 8, or x is equal to 8 and 9. Oh, wait, what did I say? It's either equal to 1 and 2, or 8 and 9. There's two sets. There's two sets of consecutive integers that work here. 1 and 2, right? 1 and 2, or 8 and 9. Two sets of numbers that work as solutions for this particular problem. All right, one more. One more. Can we do one more? Do you have it in you? I'm waiting. Let's see. Brendan claims that the number 5 has the property that the product of 3 less than it with 1 more than it is the same as 3 times 1 less than it. Tell Brendan to go home, get some rest. Show that Brendan's claim is true, and algebraically find the other number for which it is true. There's two numbers? There's going to be two numbers this is true for? I don't want to find both numbers. But that's all right. It'll be a quadratic, so we'll find both numbers. It's fine. We can do it. It's just, okay. Let's see. Brendan claims that the number 5, okay. Let's just think about this algebraically for a second here. There's a number. Thanks for Teacher Made. Thanks, Teacher Made. There's a number. You saw what it did to me right there, right? There's a number such that the product of 3 less than it, the product, so I'm going to multiply. Teacher Made, stop that nonsense. The product of 3 less than it, all sorts of crazy going on. The product of 3 less than it with 1 more than it, so x plus 1, is the same, that's an equal sign, as 3 times 1 less than it. 3 times 1 less than it, the number. Okay, so there's a number out there. He thinks that 5 works for this. Let me think. Does 5 work for this? 5 minus 3 is 2. 5 plus 1 is 6. 2 times 6 is 12. Is that the same thing as if 5 is equal to x over here? 5 times 3 is 15. 15 minus 1 is 14. I think Brendan's wrong. If I got it wrong, let me think about this. Brendan claims that number 5 has the property that the product, boom, of 3 less than it, boom, with 1 more than it, boom, is the same as 3 times 1 less than it. If x is 5, 15, 14, all right, I think this is 14. So 5 minus 3 is 2. 5 plus 1 is 6. 2 times 6 is 12. Well, this is embarrassing. I think Brendan's wrong, but maybe I am reading something wrong. Let me look at it one more time. The number 5 has the property that the product, multiply, of 3 less than 5, of 3 less than it, and it's the product of 3 less with, I'm saying it's being multiplied with, 1 more than it, is the same as 3 times, maybe 3 times, that's what I'm missing. 3 times, I thought that was some odd language there. 3 times 1 less than it. So I need parentheses here. So you see that? 3 times 1 less than it. So it's 3 times the expression x minus 1. Let me rethink about this. This side is definitely equal to 12. 2 times 6. This side here, I kept getting, 14? But if it's this, it's going to be 3 times x. So 3 times 5 is 15. And then 3 times negative 1 is negative 3. 15 minus 3 is 12. This does work. Brendan is a crazy genius. All right. So let me prove that this is true. Okay. I'm going to multiply this out. Right? And then I'm going to multiply these two things together. I get x squared. I get plus 1x. That's x times plus 1. Negative 3 times x is negative 3x. And then negative 3 times 1 is negative 3 equals. All right, and now I'm going to combine some like terms. That's funky. I'm going to combine these two like terms here and get negative 2x minus 3. And then I'm going to subtract 3x. I'm going to add 3, because remember, I ultimately want a 0 on this side of the equation. If I do that here, I got a minus 3 over here, 3x, and I got to add 3 over here, which leaves me with a grand total of x squared minus 5x. Let's see, the plus 3 and the minus 3 looks like they cancel. And it's going to give me 0. Well, I'm going to remove an x out of this thing. Just making sure I didn't goof this up. No, I think I did right. I'm going to pull an x out here. X. That's an awful x. Come on, teacher maid. Play nice. Play nice. X times x minus 5. So what I did is I pulled an x out of both of these expressions here and said, okay, so I have two possibilities. X times this expression here is equal to 0, which means either x is 0, or what is x minus 5 if that equals 0? X minus 5, if that equals 0, I'd have to add 5, and then I get x is equal to 5. So Brendan, that crazy genius, he's right. 5 does has this property. There's another number out there that has this property as well, which is 0. Woof, woof. Pat yourself on the back. You did a great job. You stuck with me. That was hard to get through. I'm sure that was hard for you to get through as well. Thanks for joining me. I'm Mr. Solt. Hope that helps. I'm not going to do the homework. That'll be for you. That'll help Mr. Baskin know, whether you get this or not. And I might periodically do these, and hopefully they'll be helpful for everyone. All right. Usually I have this little sign-off thing where I'll say I see you in class. Maybe I'll see you in the halls. All right. Have a good one.